No.
So BAC. So what would be the angle C?
X.
So that's X. And then how would you find the angle A if you knew what X was?
180 minus 2x.
Yes, and that's the answer. So that is.
Okay.
Before we do these, I'll do something. This one. So do you already know how these ones work? This type of shape.
No.
So basically, these if you have yes, angles of circumference in the same segment. So these are what's called subtended on the same arc. So this is the arc here, and you've got these two that are like sitting on the same arc. And what that means is that these two angles are the same, and these two angles are the same as each other.
Oh, okay.
So let's say this middle question, you have to find the angle C and the angle D.
So is 33 equal to C?
I don't think so. I think this one up here is 33. So any idea how you can find C or D?
No.
So how about, let's say,
Let's talk about it.
are there any angles you can fill in, any blanks?
No, not really.
How about this one?
So 180 minus 33 minus D.
So this angle here.
Yeah.
So we don't know what D is. Is there any other way you can find it?
Can we work out that the angle in front of 75 is 75 also?
Yeah.
And so that's a circle, it's 360, so 75 plus 75 and 360 minus that. So 360 minus 150.
So it'll be 210.
Yep. And then from there on, 210 divided by 2 equals 105.
Yes. And so how can you use that to get?
And then 105 plus 33 equals 138. And so angle D is 40.
Just 40?
Yeah, I think. I'll check again.
138 plus 40?
33. Yeah. Sorry, 42.
42, yeah. So that's D. How about C?
Is it the same? So it's equal. So 42 also.
Yes, well done. And you can also just do two angles on a straight line. So that's 75. This would have to be 105 to make 180.
Okay.
Okay, how about the one on the right?
Is E90 also?
I think 98. The whole angle is 98.
Oh, the whole angle is 98.
Yeah.
Okay, so E is 98 divided by 2.
What is that?
40. 49.
So let's see. So these two are 49.
Yeah.
This one is Also 49. Okay. Yeah, so any questions about that?
No?
Okay, so you just look out for the bow tie shapes. So this one, hold on a sec. So any idea what the angle A is here, how this one works?
I think I've been through these questions, I forgot.
The angle at the center is half of the angle at, sorry, the angle at the circumference is half the angle at the center.
Okay, so 40.
Yeah.
16 plus 16 equals 32. 180 minus 32 is 148. And so that's, there you go, that angle. And then 148 divided by 2 is 74.
And then how about this one?
Same, I think. So 57 plus 57 is 114. And then 180 minus 114 is 66. And so, okay. If that's 66, then the angle to the left of it has to be 180 minus 66, which gives us 114 as well. And then is the angle where 57 is incomplete? Is that incomplete area? Is it 33?
Yeah.
It's the right angle. And then 114 plus 33, which is 147, minus 180 minus 147 gives us 33, I think.
Yeah, makes sense actually. But those two are 33. Well done. Let me just go back a second. Okay, so how about this one?
The size of each angle marked with the letter A. Okay, so if the top one's 100, if that one's 100, then this angle will be 50.
Yeah.
And from then on, I'm not sure.
I believe they're all going to be 50, A, B, and C, because they're all three are sitting on the same arc, so they're subtended by the same arc. It's called.
Okay.
Standing on the same arc. In terms of that's right. Let me just go back a second. Yeah, okay, so we'll try some exam questions, see if we know enough. Oh no, hang on, I think I need to do a bit more. Yeah, let's try the last one here.
The diagrams show circle center 0.
Hang on, sorry, I haven't done enough. There was one more thing I needed to do. This one, yeah. Any idea how you find A and B in the first one?
Is 129 and A equal and 62 and B equal?
Nope.
No, that's pretty hard. Okay. Um, no, I'm not sure then.
129. So opposite angles in a cyclic quadrilateral add up to 180. So basically, these two will add up to 180, and so will the other diagonal too. It's called a cyclic quadrilateral because all four sides are on the circle.
Okay.
So you just have to find M.
Yes. So B would be 51,
Mm-hmm.
and A would be 118. Okay. Yeah.
18, that's it. Okay, how about next one?
Is C? No, sorry. Sorry. So if 140. Okay. So the incomplete part, the angle D, has to be 66, and then 180 minus 66 is 114. Then if we know that the straight line one at the top is 182, do 180 minus 108, and 102 gives us 78. Okay, and then there we know that the quadrilateral adds up to 360. So we had all the angles, get 258, minus that from 360, and we get 102.
That's it. And you'll notice that it's the exterior angle. So that was 102, the exterior was 102, that's 114, that's 114. And it's because you do 180 minus, and then you do 180 minus from that, and so you go back to what it was.
Okay.
And last one.
Is that... No, okay. Do the two same lines mean it's an isosceles?
Yep.
Okay. So 180 minus 43, 90s. Actually. Yeah, 180 minus 43 gives us 137, and that's angle E, I think.
Let's see. So that's 43. That's 43.
Oh, sorry, I got it wrong. I thought. Sorry, how did you figure out that that 43?
Because this is the triangle.
And what about the yellow part then?
I don't know what the yellow bit is.
Okay, because I thought the 43 degrees was labeling the yellow part. Okay.
Oh, I see what you're saying actually. So no, I think you're right. So they're actually saying that the yellow angle is 43. Okay. So then this is 43.
Yes, that's what I was thinking.
Okay.
And then 180 minus 43 is 137.
The problem is that we have it. There's actually three angles on that straight line, not just those two.
Ah, okay, I see. Okay, so I'm not too sure.
Is there any blanks you can fill in, like any blank angles?
Yes, the bottom angle, but I don't know what it is.
So is there any that you can figure out?
Oh yes, the angle at the tip of the triangle,
Mm-hmm.
which is 94. And then on. Yeah, from there on, I'm not too sure.
It's in a cyclic quadrilateral. Can you use that to fill in the blanks?
Oh, okay, so all add up to 360.
And opposite sides are 180.
Also, yes. They're saying that the last angle was 180. No, actually, no, that can't. No, that can't be right. Sorry, I got confused. I think the opposite angle is 86.
Yep. It's going to be 86.
And so from there, 43 plus 86 is 139 minus 180. 51 degrees is the top part. And so 51 plus 43 is 94 minus 180. 86 is the E.
Ah, okay, so E is 86. Ah, yeah, 'cause that's the exterior thing. Okay, and so what you'll see with circle theorems a lot is there's no formula. Just keep filling in the blanks until you reach what you need to reach. Any questions there?
No.
Okay. That one, that's alright, and we'll come back to it. But I think we have enough. Yes, okay, let's try this.
Is X also... Is X 360 minus 67?
Not sure. What do you know about this angle?
It's got to be equal to X.
Actually, hang on. What do you know about... So this angle here...
It's 360 minus 6.
Minus 67. And then you do... This 293.
Sorry, so is X equal to 67?
Is that right though? No. That's not right. It makes this arrowhead shape. Any idea how you can use that to get that angle on the other side of X?
We have to work out angle O, so it's not 180 minus 67, is it?
It matches up with these ones. How did we get A is 40?
Half of 80, I know, but
Yeah.
we don't have that angle, do we? The angle O.
Well, you can work in reverse.
Oh, so double 67, sorry?
Yeah.
Okay. And then 360 minus 67 times 2. Is 226, so angle X is 226.
That's it. let's see. Okay, let's try C, last one.
So 180 has to be 180 minus 110 gives us angle C, and that is 70 and half.
That would be if they're on a straight line.
Is this not a straight line?
No, it's a circle.
Okay. No, sorry, but oh, sorry, I got confused.
Yeah, I thought it was 70 first time.
360 minus 110?
Yeah.
Perfect. Gives 250 for angle C, and 250 divided by 2 gives us 125 for angle D.
I don't think so. So the arrowhead is facing down.
Okay, yes. Sorry, the upside down. Does the arrowheads have all the angles add up to 360?
That's one of the things. The other thing is that this diagram up here, the angle at the center is twice the angle at the circumference.
So 110 is okay. 55 is the angle at the top. Then it's from there. I'm not too sure how to get angle D unless we add up all the angles.
I believe D is in a cyclic quadrilateral. Okay.
So opposite angles add up to 180?
Yeah.
Okay. So 70 is D.
Well, what side is it opposite?
110?
It has to be, the corners are on the circumference. The four corners have to be on the circumference of
Uh, sorry, I don't understand.
So the it's a cyclic quadrilateral is when the four corners are on the circle, and so it's opposite sides in the quadrilateral. So what side is opposite D? Sorry, what angle is opposite D, and also on the circumference? So not in the center.
250?
Nope, that's in the center.
So 110?
That's also in the center.
Oh, okay, 55, okay.
Yeah, so that's the four-sided shape for that one, and it's on the circumference.
Okay, and so 180 minus 55 gives us D, which is 125.
So D equals 125. And so to do these, you have to use different things. So one is the angle at the center is twice the angle at the circumference. That's one rule. Another rule is opposite sides in a cyclic quadrilateral are equal or add up to 180. And so you have to kind of mix and match different rules to put them to do them.
Okay.
Let me just see. I think we'll be fine there. I think these are okay. What is the angle I? No, actually, that's not what I was thinking. Sorry. No, I think that one's okay. Yeah, that's okay. That one's okay. That one's okay. Okay, let's no, that's something different, and then we get to those. Okay, so go to the exam questions, but they're not easy. That's all. And there's just one thing we haven't done that we might have to do. Wow, seems like a lot of them rely on a certain thing. Okay, let's try this one.
Okay. Is E 100?
Yes.
And I'm just gonna. Okay. And so B would be 55. ABC output. Okay, and then from there, the angles that are complete on the circle, if you know what I'm talking about, angle E in that area would have to be 160 divided by 2 is 80, so
Yeah. Each of those is 80.
yeah. I'm confused for me.
Well, what angle are you trying to find?
D, I'd say. D or A.
The question says find the angle DAC.
Okay, but to get to it, I thought we have to get D maybe first.
So I think that's true. What I'm thinking is, what I usually look out for is like a radius or a diameter. Do you have either of those in?
We have a diameter, AC.
And so is there any way you can use that to get an angle?
No, I'm not sure.
So you did it earlier. Let me just show you. Okay. Don't know if it was just luck or what, but you got it. Wow. Any idea what the angle A is in the first one?
No.
You know the way the angle at the center is twice the angle at circumference?
Yes.
Well, in this case, the angle at the center is 180 because it's a straight line.
Okay, yes.
And so A would be?
90?
Yes. And so basically the opposite angle when you have like the angle at the circumference when it's a diameter is always going to be 90. So
okay.
It will be half of the 180. Let's see. I'll use that.
The fact, okay, so point O is 180.
Okay.
So is D 90 also?
Well, D isn't in a triangle where one of the three sides is the diameter. So if we look at the diameter,
Yes.
so let's see, so that would make this triangle. I think that's the only triangle. And so what would be the 90-degree angle?
Okay, angle B. So 90 minus 55 is 35.
Yeah, so that's 35.
Sorry, so where's the... Sorry, what angle am I trying to find now? D?
So eventually you're trying to find this one,
Yes.
but so you're saying you'll need this to get it. And is there any way you can use 35 to fill in a blank?
Oh yes, I don't remember the name, the Z angle. So is angle D also 35?
No. Could you get this one here, the C?
Yeah. Uh, 65.
So it'll be 65. And so what you may or may not notice is this arc. You've got two things sitting on it. So one is this red triangle, and what's the other triangle sitting on it?
DAC or
Yeah.
DA.
And so how can you? What does that tell you?
Are they equal?
Is what equal?
Could it be that angle D is also 65?
Yes.
Okay.
They're both subtended on the same arc. So now we have D.
And so 80 plus 65 is 35.
And so that is 35 degrees. So again, maybe we didn't need the 100 on this side, or maybe we did, but just slowly but surely fill in the blanks and get to where you need to be. So that's 35 degrees. Any questions about that one?
No?
Okay. There's one type that I think we need to do in terms of why. Okay, let's do this.
So D is Y divided by 2.
Yeah.
And then would Y plus 180 equal angle B?
Well, this one is y over 2.
Yeah.
What do you know about that and this?
Are they... Oh, okay. Yes. So Y over 2 plus the number has to add up to 100 and... Y over 2 plus B has to add up to 180, I think.
Yeah. And so we want B.
So times 2 plus B. We want Y or B, so...
Just B.
Okay. So 180 times 2 minus Y.
It doesn't... Well, then you'd have to divide it by 2, because I would just move it over.
Okay. 180 divided by y2.
So this is y over 2 plus b.
Or minus y over 2.
Yes.
Okay.
So you just minus that from both sides.
Could we not times 2 on both sides and then... No.
So
What is it?
if you times both sides by 2, you'll
It
get
means just-
y, you'll get 360, but then you'll get 2b.
Okay.
And so you'd get 2b equals 360 minus y, and then b, you'd have to half everything, and so you'd get 180 minus y over 2. So same thing.
Okay.
Yeah, any questions there?
No?
So they tend to like that shape and putting them together. So that's a pure algebra one. I think there's one more thing you need to do. I think you'll be fine for these. I think you're... No. Let's... Okay, we'll do one last one.
So D has to be 64.
Mm-hmm.
And then... $116 has to be half of O.
Nope. It's not an arrowhead.
Yeah, sorry, it's not. So X has to be double 64 then.
Yeah.
Which is 128.
128 degrees. There we go. Let's see. Find the size of angle A, D, B. I don't want to... Okay, so we've done those. There's one kind of important one that I want to do. Theorem. Where's this shape? This one. So we drag this point, and so basically a tangent intersects, always intersects a radius at 90 degrees. Is that what this one is? Any two tangents from a single point are the same length, so the angle between the tangent and the radius drawn is 90 degrees. So that's always a 90 degree angle from the between the tangent and the radius. That's 90, that's 90. So how do we do this? We find this angle here.
First of all, 180 minus 101.
Mm-hmm.
Say that's 79.
Mm-hmm.
I'm not seeing that.
The tangents are the same length, and so the angles will be the same.
So is the one above 101 as well?
Yeah. So you said the other one was 79.
Yeah.
So how can you use that to get A?
Not too sure.
So if this one up here is also 101,
Yep.
and then the other one will also be 79.
Oh, okay. So it's a isosceles triangle.
Yep.
So 79 plus 79 is 158, and 360 minus 158 is 202, I think.
So it's just a triangle, so they add up to 180.
Yeah, sorry. It's 22.
So that's 22. That's it. So let's do these exam questions again. So I just noticed that fact came up a lot. Yeah, okay, let's try this. You have to find the angle DOA.
Um, oh. Is B90?
Yeah.
So 34 plus 90. 56. Oh, so O, the, yes, that angle is 56. Is the angle labelled red 56 as well?
No. So there, this is C. This is a tangent at A, this is a tangent at B.
So is A 90 as well then?
Yeah.
Okay, so no. No, I don't see how to get the...
Tangents are the same length. And so what do you know about this angle? This will also be 34.
Sorry, how?
So these two are both tangents to a radius are the same length.
Okay, yes. Okay. And so the middle angle is 56 as well?
Mm-hmm.
And so 56 plus 56. 68 is the DLA.
So that is 68. 68, that's it. So we did, oh yeah. SOT. Alright, let's give this a go.
So angle P is 24. No, sorry. Half of angle P is 24.
Yeah.
So the whole angle is 48. Is angle O also 48?
No. Looks a lot bigger.
Okay. Is the exterior of angle O 360 minus 48?
No, that would
Oh,
only
wait.
that would only be true if this was 48. Is there any other blanks you can fill in?
Sorry, the exterior of angle O isn't 96, is it?
Say the answer?
48 times. The exterior of angle O, is that not 96?
No. So you're thinking of...
Yes. No, let me see.
These are tangents. What do you know about tangent on a radius?
No, can't remember.
For this one, BC was the tangent, so was AC. What happens when the tangent meets the radius?
Is it 90?
Yep,
Okay, so TLS are 90.
yep.
So it's angle A, angle O 132.
Yes. 32. Okay, let's try this one. Let me see.
Our angle, no. Our angle DMB 90.
So that's 90. That's 90. And then you just fill in the blanks from there. Like what would this angle be in here?
90 plus 75 is 165, so 15.
So that's 15. And we just do more stuff. I just don't want to. Let's see. I'm trying to make sure. I'll just go to your. And like always, it's not obvious. You just fill in the blanks till you get there. Calculate the radius of the circle. Actually, have to find the length of the radius. Okay. So, OB is a radius. OA is a radius. They're both. You see how they're both on the same arc, AB?
Yes. Yes.
So, can you see any angle that would be the same as 54?
A by any chance?
I believe it'd be O. O matches up with C. So that's 54.
Sorry, is that the same triangle?
So there's one triangle ABC, and then there's another triangle AOB.
Yes.
So O and C match up with each other because they're both subtended on the same arc.
No.
So that both triangles are sitting on the same arc. That arc there.
Okay.
So with the 54, any idea what you can do next? And the blanks you can fill in.
54 minus 180, which is 126, and then divided by 2, which is 73.
Is it 63?
63, sorry.
And so, what angle is 63?
A and B.
Yes, because there's a radius, that's 63, and that's 63. And then any idea how you would find the size of the radius, like OA or OB?
No.
So you could use sine rule or cosine rule. So, do you remember how you do it using sine rule?
Does it have to be a right angle triangle for it to be a sine?
That would be Sokotoa you're thinking of?
Yes. So 14 over 54.
Sine 54.
equals AC over sine 63.
Sine 63. Yes, and it would be technically OA, not AC. AO.
Okay.
So we want the radius.
I
Okay.
thought that yes.
So how do you get OA?
Times sine 63 on both sides.
Yeah. Sine 54. Let's put that in the calculator, and that's the answer. And it's 15.4 degrees. So
Okay.
there's an extra one because for that one they incorporated sine rule. Like, had to find a length, whereas what we saw in the exam questions is they never want a length, they always want an angle, and they always give you some information. Let's just see. So I think the main things, let's see, main things to look out for. Yeah, so this one is if two angles are subtended by the same arc, then they're equal to each other. And so that's why it makes that kind of bow tie shape. So A is 24, B is 19.
Okay.
C and D are the same in this one.
Yes.
And we can use that. That one actually doesn't come up a lot. This one comes up a lot. The angle at the center is twice the angle at the circumference.
Okay.
And this one where you knew it was 90, this on the outside is 180. So if it's a diameter, the angle opposite the diameter is 90 degrees.
Okay.
What do opposite angles in a cyclic quadrilateral add up to?
180.
Yeah. And so you just keep using those same rules over and over again, but you're just mixing and matching them. And, for higher and higher mark questions. But it's the same stuff, and you just keep, mixing and match. How was that for you, Hugo?
Quite difficult, honestly. We need to revise that more.
So I think circle theorems are grade 9 as well. But there's lots of exam questions, so it comes up a lot. But it's a lot of work to get those marks. So any topic in particular you want to do next?